For part C, we're told to let t seconds be the time that AB is watered. So that is that arc length there in each revolution, and we need to find t. So we need to know what angle makes up that arc AB. So it's this angle here. Okay, so if I call this one theta, that will also be theta. So what we want to do is find theta, and then we can work out 2 theta, and then we'll have our angle in radians. And we can do that just using Pythagoras. So we know that cos of theta would just equal adjacent over hypotenuse, so 14 over 20. So therefore, theta is the inverse cos of 14 over 20. And we can work that out on our calculator. So we'll get that up. So we just need to do the inverse cosine of 14 over 20. And it is that there. So we'll make a note of that. Okay, so it is 0.79538 and so on. And we want 2 theta. So we'll just multiply that by 2. So we have our answer, and we'll times it by 2. And we get that 1.59079 and so on. Okay, so write that at 1.59079. So that is our angle theta. And we know this. We know that 2 pi radians is completed every 16 seconds. So that would be 1.59079 radians every, this is what we need to work out, every t seconds. Okay, so don't get confused just because we're working in radians. It would be the same thing. Just do a quick example over here. If we're doing speeds, for example, so if I was doing like 2 meters every 16 seconds, well, that'd be the same thing as going, say, if I wanted to go 8 meters in 64 seconds, because we just times everything by 4. Okay, so it's exactly the same process here. And now we can just rearrange to find t. So therefore, t is equal to 1.59079 and so on, divided by 2 pi over 16. You can simplify it if you want, but as we've got our calculator, I'll just leave the expression as it is. So we'll go and solve that on the calculator. Okay, so just bring that answer down there, and then that was divided by 2 pi, so 2 pi over 16, and there it is there, 4.0509 and so on. So this equals 4.0509 into 3 significant figures. T is equal to 4.05 seconds.